years, the concentration has been unraveling the secrets of mysterious exoplanets scattered across our galaxy. There are most likely hundreds of billions of stars in the Milky Way, so it doesn't happen that we haven't found other cosmic entities beyond our solar system. This has been done numerous times with great precision, but this is the first time we have been able to capture direct images of a planet that isn't geographically close to us with impeccable accuracy. This planet is either different from what we thought previously, or even more mysterious than we had imagined. Inspiring images from the most powerful space telescope ever constructed have left us in shock. Scientists have been tracking it as it orbits the Sun at 1.6 million kilometers or miles from Earth. NASA made history by taking the first direct image of an exoplanet outside of our solar system using NASA's James Webb telescope. The planet is a gas giant, meaning it is uninhabitable. This image of the exoplanet demonstrates Webb's power when pointing worlds beyond our solar system, since there is no rocky surface seen through 4 different light filters. These observations may help narrow down the planet's size in the image, rather than just confirming the planet's size in the picture. The Earth in the photo is approximately 6 to 12 times the mass of Jupiter. The planet is also fairly young. Considering how old some planets are, it is estimated to be approximately 15 to 20 million years old, compared to the Earth's 4.5 billion years. Considering that this planet was discovered in 2017 by astronomers, it's a little toddler. A sphere instrument on the European Southern Observatory's Large Telescope in Chile was used by astronomers to take images of it. Now we have a photo that astronomers captured using short wavelengths of infrared light. The intrinsic infrared glow of the Earth's atmosphere makes it impossible for surface-based telescopes to detect new details due to Webb's view's longer infrared wavelengths. The data collected from these observations are being analyzed by researchers currently preparing a paper for submission to journals for peer review. However, Webb's first capture of an exoplanet already gives researchers a glimpse of the possibilities for studying distant worlds shortly. A large international team led by Sasha Hinckley of the University of Exeter in the United Kingdom carried out these observations. It revealed a monumental moment for Wian's astronomile. In various infrared light rays, this image shows the exoplanet HIP 65426b from the James Webb telescope. Purple symbolizes the NetCam instrument's view at 3 micrometers, blue signifies the NetCam instrument's view at 4.4 micrometers, yellow indicates the MIRI instrument's view at 11.4, and red indicates the MIRI's instrument's view at 15.5. In micrometers, every image looks different because the instruments record the light differently. A coronagraph with each instrument blocks the host star's light, so the planet can be seen accurately. In every image, the planet's host star, HIP 65426, can be seen. This star position has been obtained with the help of the coronagraphs and the instrument's image processing tools. The bar shapes and the NetCam images are artifacts of the telescope's optics, and they are not to be mistaken for the actual objects in the scene. It is enough distance from its host star for the Webb to separate HIP 65426b from it, as it is about 100 times farther away than Earth from the Sun. NIRCam is Webb's near-infrared camera, and MIRI is his mid-infrared instrument. Webb's NIRCam and MIRI have been equipped with coronagraphs, tiny masks that block out starlight, allowing Webb to take images of certain exoplanets like HIP 6426 directly. Adding to his comments, Hinckley further reported that the Webb coronagraphs worked well in suppressing the star's light, but this raises a big question that needs to be addressed. Since stars are much brighter than planets, it is difficult to take candid photographs of exoplanets since they are much further away from us. The near-infrared transmission of HIP 65426b is over 10,000 times fainter than the transmission of the host star in the high infrared and a few thousand times fainter. Each mid-infrared filter appears to show that the planets are roughly shaped blobs of light that seem to differ in their shape slightly. This is due to the nature of Webb's optical system, the efficiency with which light is processed by Aaron Carter's various optics, and the nature of Webb's optical system. Analyzing these images at the University of California, Santa Cruz felt like I was digging up space treasures as a researcher at that institution who helped analyze the photos. It took me some time to determine that there was still a planet in the image and that it was not just some light coming from the star. Still, it was a case of careful image processing that enabled me to remove the light and show the planet within. Even though this is not the first image of an exoplanet taken directly from space. Hubble has already captured a direct image of an exoplanet, but HIP 65426 is setting the standard for Webb's search for exoplanets by providing a glimpse of what is to come. I think the most exciting thing about this whole topic is that we are just at the beginning of our journey. We'll continue to find and photograph images of exoplanets that will help us understand more about the physics, chemistry, and formation of planets, as well as possibly find previously unknown planets. This discovery has paved the way for many more discoveries to follow in the future, thanks to HIP 65426b's prospects. During Webb's exploration of the exoplanets in our galaxy, scientists will examine a sample of the more than 5,000 novel worlds recently confirmed to exist in our universe, and they will begin to piece together the story of their birth and death. As we have all figured out, scientists have discovered that exoplanets come in a wide variety of sizes and types, but the Webb, like we've all come to recognize, can reveal details of the universe we've never seen before. NASA, the European Space Agency, and the Canadian Space Agency have worked together to create a $10 billion Webb telescope, likely setting decades-old debates about how planets form and die. As part of the project, exoplanet atmospheres will be measured in 3 dimensions, and their structure will be explored in 3 dimensions. This could begin to give us a better understanding of how planets are like our smaller rocky planets and what it takes to make them habitable. A Carnegie Institution of Washington staff scientist who is co-leading NASA's Ames Research Center's Webb observation team, Joanna Tesk, said we're at the threshold of an explosion of knowledge about exoplanet atmospheres. A better understanding of their mass or size will allow us to move the magnifying glass around among future projects and learn more about them. In the next few years, NASA's Nancy Grace Roman Space Telescope, set to launch later this decade, will improve our view of exoplanets in a significant way. With its first images released in July, the coronagraph Webb has already revealed stunning details about the phantom galaxy end of the planet. The new technology will demonstrate an even more advanced coronagraph Webb. As Jupiter's excitement grows, Erin Carter says, "I think the most exciting thing is that we are only just the beginning, and we might even find previously unknown planets. We're pretty sure this is the beginning of something truly remarkable. Can you tell me what else the James Webb Telescope will discover in the near future, and if we discover habitable planets?" As always, thanks for watching Space Tech Future, and let us know what you think by leaving a comment below.